Yeah, yeah. Because it's not a simple process. Guys.
I don't know how to write.
Let's see. Let's see. Yeah.
80? Don't write that.
And equivalent expression using only sine and cosine, and then simplify. All right. So, just going to practice some of these. What can happen here is there's a couple different ways you might be able to start a problem, and one takes you to a nice simplified answer, and one takes you into a brick wall. So that's what makes these a little challenging. If you run into the brick wall, you got to go back to the beginning and say, okay, I can start this other way. So it's not like follow this process, because there can be a couple processes to follow. Okay. So we've got cotangent times sine. So we will start easy and work our way up. You may want those identities out from yesterday, because we're going to be using all of them. Okay, so the first one, the rule is switch everything into sines and cosines and then simplify as much as you can. While sine is already sine, you're going to leave that alone. We want to switch out cotangent. Do you remember from yesterday how cotangent can be rewritten? It can be rewritten with your quotient identities. Cotangent equals cosine over sine. It could also equal 1 over tangent, but I want to switch everything to sines and cosines, so I wouldn't want to pick this one. You want to use this one. So, we're going to rewrite cotangent as cosine over sine.
I don't want them to do I don't need them.
I'm going to leave sine alone, but because it's next to a fraction, and I know I can simplify, things are in the right spot, I'll make it sine over 1. Now it's very easy to see what's going to cancel out. What's going to cancel out? Sines are gone. What am I left with? Cosine. Can I get any more simplified than a cosine? No, it's as far as that one will go. Easy one.
Is there ever going to be like cosine times sine times
Well, there's going to be lots.
tangent times...
Oh, yeah.
It's the same stuff.
All just same idea today. We're only doing this kind of example. All right. Sometimes it's helpful on this one. Maybe we can simplify first. I see a 1 plus tan squared. And the more we do these, the more you'll get used to it. When you see a squared function with any kind of a 1 combination, they look very Pythagorean-like. Let's check the Pythagoreans and see.
Equals something.
Does that equal something?
Yes.
Where are my Pythagoreans at?
You can't.
1 plus tan squared does happen to equal secant squared. So let's simplify that first. Okay. Now we still did not use the trick of switch everything to sines and cosines to see if anything will cancel out. Well, if this was just cotangent without the squared, how do we rewrite cotangent? Cosine over sine. Well, because it's cotangent squared, how do you think I'm going to rewrite it?
Cosine squared over sine squared.
Exactly. Cosine squared. Oh, it's supposed to be secant? Thank you.
Are you kidding me? Right now?
It is supposed to be secant. Oh, look at, then I write secant down here. Sine. Sine. Okay.
What, because I helped her joke?
So I've got secant squared. Guys, stay focused. Secant. How do you rewrite secant?
1 over 2.
1 over
Cosine.
cosine. So secant squared would be rewritten 1 over cosine squared. What cancels out? The cosine squareds are gone. What's left in their place when you cancel them out? Yep, I've got 1 over sine squared. Does that simplify?
Yeah, probably.
Forget about the squared for now. What's 1 over sine equal to? Cosecant. So what do you think 1 over sine squared equals? Cosecant squared.
Yeah.
So if you can get rid of the fraction, that's considered simplifying.
What is that?
Cosecant squared. CSC squared. Okay?
Miss Roy?
Yep.
How did you go from the cotangent squared, secant squared to the cosine?
Cotangent, just cotangent is cosine over sine. So if I've got cotangent squared, I just got to square these.
Okay, so what happens to the secant?
Secant is 1 over cosine.
Okay.
So it's secant squared would be 1 over cosine squared.
Right now.
So the final answer is like, oh, in the cosine. Oh.
Are you a little behind on that one?
Yeah, I just got lost.
All right, number 3. Let's go with
Now.
1
It's like a weird way to put it.
minus sine squared over 1 plus cotangent squared. So what did I tell you to look at anytime you've got the squared functions with the 1's attached?
Look at those.
Look at the Pythagoreans. Can I get one of those Pythagorean identities to be 1 minus sine squared?
I'm sure you can.
Yeah.
I'm sure I can.
Cosine.
Take a look at this one. Can you rearrange this one to say 1 minus sine squared?
Sure can.
I subtract sine squared here. I have 1 minus sine squared here. What's 1 minus sine squared going to equal in your head? Cosine squared.
Ow.
Do I need to write it out or can you see it?
I can write it out just for the sake of it.
Okay. So what we're going to use, cosine squared plus sine squared, oops, forgot my little theta, equals 1. I want this to say 1 minus sine squared, so I'm going to subtract sine squared on both sides.
Why are you writing it over there?
Just to show us. Yeah, can you not?
So that means cosine squared equals 1 minus sine squared. So what I'm allowed to do now is rewrite the numerator as cosine squared. Okay, how about 1 plus cotangent squared? That looks Pythagorean-like. Here I've got cotangent squared plus 1. That's the same thing. That equals cosecant squared. So the bottom is cosecant squared.
Yeah, I mean,
Okay. Now we still have to switch everything to sines and cosines at this point. So we did a little simplifying. Now you want to switch everything to sines and cosines and see if you can simplify any more. So cosine squared is going to stay cosine squared. How do I rewrite cosecant squared in terms of sines or cosines? 1 over sine. 1 over sine squared. Okay? How do I divide by a fraction? No.
reciprocal.
Multiply by the reciprocal. So I'm going to keep cosine squared. And I'm going to multiply by the reciprocal of 1 over sine squared, which becomes sine squared over 1. I don't need the over 1. I got cosine squared times sine squared. Good?
Yes, we're done, right?
Not quite. Just going to practice some more of these. There's not much today.
I'm sorry, wait. That's not,
That doesn't go anywhere. Cosine squared times sine squared, that doesn't do anything. If that was a big old plus in there, I could make it 1, but it's not. I
just don't get how you get from the... Alright, never mind. I see it now.
Okay.
Well, what about from the first part to the second part?
That was the Pythagorean stuff over here. I used 2 Pythagorean identities to go from the first step to the second step. I took the cosine squared plus sine squared equals 1 and I rearranged it so that it says 1 minus sine squared. Now I know 1 minus sine squared equals cosine squared. So the whole top equals cosine squared. And the whole bottom equals cosecant squared. Because of this one right here. Cotangent squared plus 1 equals cosecant squared.
Alright.
Okay, number 4.
I'll be dead.
Sine
No, you won't die.
times cosecant minus sine. Okay, if I left you alone on this one, what would you do first?
We would do the middle part.
What do you want to do with the middle part?
We gotta make it equal something. Okay, good job, Kevin.
That's not going to equal anything. So there's the brick wall right off the bat. You can look for a long time, but that's not going to...
1 over cosine equals, you gotta subtract them.
I could do that. I can't subtract them. Nope. Oh, I like distributing. Let's distribute. See what that does for us.
No, wait, no, I figured.
We had already started.
Cosecant can also be 1 over sine.
Yes.
And then you just, roll from there.
Yes, that could be done first, or this could be done first. Either one. So there, eventually we're going to switch that to 1 over sine.
You did it right about that.
So sine times cosecant. Okay, the conversations really need to stop. They're driving me nuts. And then minus sine squared. Now at this point, you could say, like Kenley noticed, and somebody else said right off the bat, we could switch this to, I think it was Alexis, 1 over sine.
No, I said that.
Or you could look on your identities and know that sine times cosecant equals 1. If you need to switch it to the 1 over sine to get there, that's fine too. But sine times cosecant, because they're reciprocals of each other, equals 1. Then I've got a minus sine squared. Does that simplify anymore? Looking Pythagorean again, isn't it?
Yeah.
What does it equal? Cosine squared. Right off of the Pythagorean identities. Okay. Number 5. I have 6. Tangent
Good question.
of negative theta,
How many are we doing?
secant theta.
Oh, wait, where did the cosine squared theta come in?
Pythagorean. Right this one. Cosine squared plus sine squared. If I subtract sine squared from both sides, 1 minus sine squared equals cosine squared.
Does the negative not matter?
What the heck happened?
Or the subtraction?
Yes, it matters.
What?
Did you watch me when I rewrote that one over here? If I start with cosine squared plus sine squared equals 1. I want to arrange this so that I have 1 minus sine squared. I can do that very easily if I just subtract sine squared from both sides of this. Over here I'll have cosine squared equals 1 minus sine squared.
So if it would have been 1 plus sine squared?
Then I would not have been able to use this. Couldn't have done. I could never get this to say 1 plus sine squared no matter how hard I try.
What would you use it?
You'd have to leave it as that. You couldn't do anything with it. It would stay 1 plus sine squared. Okay. So they don't always fit, but most times they do. All right, what would you do first on this one?
Switch the tan.
Yeah, take care of this negative theta in here with your negative angle identities. That's a perfect start. And the tangent of negative theta equals negative tan theta. So the top is going to switch to, I'm going to move horizontally here, negative tan theta.
I have a question.
Yes.
Okay, so secant is pretty much 1 over cosine, right?
Yep, that's where I'm going. So we're going to switch secant to 1 over cosine. What do you want to do with tangent?
Multiply by the reciprocal.
Not yet.
Not that.
Not yet. I just switched secant to 1 over cosine.
Yeah, why did you move it over there? Is negative tan theta the one on top of that?
Yep, what am I going to switch negative tan theta to? Austin?
And then just say that?
Nope, that went right back to here where I started.
Just kidding.
Don't want to go back where I started.
Ignore me.
If on a test, if we didn't put like those Easter egg looking things in there, would you be mad?
Negative sine over cosine?
Yes, switch to sines and cosines. So we carry the negative along. Tangent is sine over cosine. Yes, you've got a fraction divided by a fraction. So we go back to 7th grade. Keep your numerator one the same. So negative sine over cosine. Multiply by the reciprocal of the bottom.
And cross out the cosine,
Cross out the cosines.
and then we have negative sign.
Negative sign is as simplified as I can get this thing down to.
So if it comes out negative, then there's nothing you can do.
Well, there's only one term there.
Oh,
Not much I can do with one term.
that's true. We're both trying to figure out.
Last one.
Figure out how to start it.
Wait, time out.
Yeah, once you figure out the start, if you can get on the right road to start with. But a lot of times there's a couple different ways you can start. Sometimes both roads meet. Sometimes you fall off the cliff.
I usually just fall.
Bless you. Bless you again.
Do it again.
Oh, right.
Three phase. I really cannot help it. I'm allergic to life.
Yes. Yes. This one's got a few steps to it. Okay.
That is also very accurate. Actually, you know.
Okay.
Ouch.
Conversation. Stay with me for this last one. What's a good start for this problem?
Pythagorean.
Are there any squares in here to say Pythagorean?
No.
No, no squared, so not Pythagorean.
Distribute.
Distribute, FOIL. FOIL would be a good start.
We're gonna foil your plan.
FOIL.
Ooh.
So 1.
Don't listen to me.
I understand this.
Yeah. I don't know, like horseshoes.
Not everyone can do that. Do you want to stop with each other?
All right.
Okay.
Here we go.
Is there anything I can simplify in that line?
Cosine secant
Well, what is cosine times secant?
equals 1.
That equals 1.
So can we just get rid of the one in the beginning since that's the
Yep.
first one?
Yep, so I got a 1 and a minus 1. I'm left with secant minus cosine. Okay, we have not switched everything to sines and cosines to see if we can do anything.
In this one, can you not even like bring tangent into the whole equation?
We don't want tangent, we want sines and cosines. So, how do I rewrite secant?
Well, I didn't know if it was illegal.
1 over cosine minus, and I'll make this cosine over 1. Am I allowed to cancel those cosines?
No.
No, not over an add or subtract sign. Never ever. Only if they were multiplied, like up here. When things are multiplied, you can cancel. Okay, the only way for me to bring these two things together is to get a common denominator. Here I've got a cosine, here I've got a 1. What's my common denominator?
Cosine.
So I need to hit this one with a 1. So I'm going to multiply the bottom by cosine, which means I have to multiply the top by cosine. So far so good? So I'll have 1 over cosine minus, what am I going to have here? Cosine squared over cosine. Now that there is a common denominator, you can add the numerators together over that common denominator. So what's my numerator going to be? 1 minus cosine squared. Looks very Pythagorean. So the numerator is Pythagorean. If you look into your Pythagoreans, it equals sine squared over cosine. And I am perfectly happy with that answer. Big old smiley face. The book does go a few more steps to get rid of the fraction in there.
Can't you do more, or?
You can. I am happy right there.
I'm happy too.
We're all happy.
We're all happy.
I'm not happy, thanks.
Okay, I will show you what the book does to eliminate the fraction. So what the book does, makes this sine, you don't have to write this, just take a look, sine times sine over cosine times 1. Do you agree that I've got the same thing as I had here? Sine squared is sine times sine. Cosine is cosine times 1. If I multiply these two together, what is sine over cosine? Tangent. And sine over 1 is sine. So they take it 2 more steps. I am perfectly happy, smiley face, right here. Okay, you get to try a couple from yesterday and then some of these, as soon as I find my book.
I wouldn't feel like we would have to be able to fix that early argue. No.
Did I what? Did I miss your homework? No?
No, you checked it.
Wait, what's the 19th? It's a Monday.
All right. So